Alright, so let's talk about what I've done here. We're kind of out of the prototyping stage, a little further into the getting closer to final build for this controller. Let's talk about the components real quick. So this is a motor that is for RV steps. So it actually causes, when you open an RV door, you push a button, the steps power extend or whatever for those $60,000-$70,000 RVs. Yeah, that's what this is. So that's an RV power extend step motor. This is a reversing relay, and you supply power to it through these two wires and hook it up to your motor through these two. And these three wires over here are the reversing triggers. So this black wire right here is a common, and these guys here, you see it says forward and reverse. When you short these to that common, it triggers this to run the motor in one direction or the other. So we use this timing relay, currently set for a minute, so we actually have some time, but not too much time to demo this. And what it does is, on time 1 and time 2, each of these are set for 1 minute. So it's time on, time off. You can set up to 1,000 minutes, I think, on each one of these if you really want. So yeah. This is a 12 volt 10 amp power supply to be able to run this motor. And then we have limit switches over here, which are industrial limit switches that are meant for high humidity and wash down environments. So these can get wet. And then we have this thing here. This is kind of like a breadboard or something that goes in a box right there. That's a waterproof, humidity proof box. And kind of all fits nicely. I'm going to put some glands on these to keep the water and humidity out. The penetrations into the box will get these rubber glands on them so that the box seals. So, and we got 120 volts of power here. Now, what does this do? So this motor's running, and picture for a moment, if you will, a tray that's going like this back and forth, right? So when the tray hits a certain tilt, you want it to stop the motor, and that's what these are for. So once it hits a certain tilt, it'll stop the motor. So, all right, it's this one. So it'll stop once that tray tilts a certain distance, and it'll stop for a certain time frame. So you can set it for an hour, and it'll stop for an hour, and it turns off the relay, turns off the motor, and it stops. It doesn't run anymore, because what you don't want is that motor overrunning and killing the mechanism, like through mechanical crashing, right? So we want that motor to stop at a certain limit. And you can adjust all that with these. You got a screw, you can adjust its position on this limit switch. So these will limit how far that tray tilts, right? Back and forth. This limits how often it does it, goes back and forth. Now say, for example, and I know this looks like a mess right here. Say, for example, the trays are tilted all the way, and you want to get some eggs out of the incubator. Tilted at a 45-degree angle is kind of difficult to get a tray out of an incubator. You don't want to pull it out at a 45-degree angle because you lose eggs or hatching eggs or whatever. So you want to run it backwards so it is level again. So what I've done here is, with this relay, we have the common on a little spade connector here, and we have two connectors here that run through the loop of the opposite, so the one that will be triggered at that time. What we're going to do is make it so that you can push a momentary button and run it the other way. So I'll trigger this one. So right now we're in stop, right? So right now it would be completely, fully in the opposite direction or whatever, locked, right? So we want to pull our tray out. So all we do is push our button, and it runs the opposite direction. See that? So push your button, it runs in the opposite direction. So I'll put buttons on the side of the box that you can push to run the tray in the opposite direction. I'm also going to put a switch, one of these guys, to turn the power on and off, so that you can run it 2-0, flip the switch, turn the power off to the whole thing, and do what you need to do. And then when you're done, flip it back on, and it'll resume at 0 time and count up again to 45 minutes or an hour or whatever. So you might get a 1 or 2 extra cycles in there, but with this setup, you'll be able to cycle back and forth on a time frame and be able to pull eggs out with your momentary buttons. So limitations? None. There's no limitations. Sky's the limit. I guess there is a limitation if the sky's the limit, huh? Anyway, so caveats, right? This guy is not a continuous run motor, and it's actually really quite hot right now. So I'm actually going to turn this off while I'm talking about this. Doink. Yeah, so I'm going to build in a couple safety protections too. I do believe that this has a fuse in it, but we don't have a fuse after. So if anything in here dies, it'll just be straight power going through into this stuff, and we don't want it to basically catch fire and burn anything down. So fuses, we need to put a few fuses in here, and then we're pretty much done, except for this shaft right here. So if I peel this tape off, you can see that this shaft has 2 keys in it, 2 flats to make it a keyed shaft. Unfortunately, the mating shaft that this will go into has a cut across here in the center. The problem with that is I'm going to need to shave this down so that this can fit into that cut. What I'm going to have to do is mark it at a certain, so like put some Dychem or blue, Prussian blue on top here, and mark it a certain distance in, and then shave off the amount of metal into that location or into that marking, because what will happen is if you don't get it even, this will want to weeble wobble back and forth like this as it's rotating, and we don't want that. We want this to be nice and even. So as it's rotating, it stays still, because it'll wear out the screw holes as it's fighting back and forth. So we don't want that. Other caveats, I guess. So Meanwell is a good PSU brand. Automation Direct stuff is, it's all straight from China, but it's vetted high quality stuff. So both the Meanwell power supply and the timer relay are both high quality, same as the limit switches. The only thing that is not high quality here is this, and this is on purpose. This does a lot of cycling back and forth. So what we want is a weak link. This is $17. This is 40, and this is like 70. This is 80, I think, and these are $39 a piece. So we don't want our expensive stuff to fail. We want the control here to fail before anything else, or preferably a fuse that we put in line here. So this will be the weak link, and so will the fuses that I'm going to put on this hot side. So, right, momentary switches are all that's left to do. I got to order a few of them, waterproof ones, and high cycle, so that you can, they will more than likely have a rubber gland. Hawk hair, god damn it, this freaking dog. They'll more than likely have a gland like this on top, a rubber gland, so that it keeps the moisture and condensation out of the box. So I need to find a couple of those to keep it all nice and sealed. And then once that's done, we're pretty much complete. And then it's time to install in the incubator. So, right. If you have questions, ask. If you like this video, subscribe. If you hated this video, downvote. And if you have questions, ask. I know I said that twice, but you know, instead of downvoting stuff, just ask a question or tell me why you didn't like it. So anyway, hope you learned something and have a good day.